Good day, everyone. So today we will be having another module, Module 9, here in Math 152, Math 171. But this module is about the differential calculus part ng ating subject. So here in our module, ang focus natin is the polynomial curves, mainly yung tangent lines and normal lines. And also we will be discussing later the first derivative test. So before we dive deeper sa ating topics sa Module 9, let us first see the learning objective para alam natin yung target natin in this module. So first, we will be able to relate the significance of the slope with the equation of the tangent and normal line. So if you remember from our previous module, or previous modules is meron tayong na-touch na topic na slope wherein we stated na every point along the curve is iba-iba ng slope. So yung concept na yun is gagamitin natin dito sa ating module number 9. Okay? So dito is solve natin yung equation ng mismong line o tangent line at that specific point. Okay? And nadadagdag yung normal line na concept which we will be discussed later. So next, we will be able to find the tangent and normal lines to a curve at a given point. And then third, define and illustrate geometrically increasing and decreasing functions. And lastly, our learning objective is for us to be able to apply the first derivative test to find relative extremes of a function. Okay, so ito yung mga target natin or targets natin in this module. So first, i-discuss natin yung first part ng ating module 1, module 9, which is the polynomial curves, tangent and normal line. Okay, we have here the graph of the curve y is equal to f of x, wherein we picked o kumuha tayo ng isang point sa curve and the label niya is p sub 1 with its coordinate na x sub 1, y sub 1. Okay? So sa point na yun, sabi natin sa previous module, sa isang curve, sa curve natin na yan, kada point niyan is iba-iba ng slope. Okay? And then nabanggit din natin sa previous module natin, hindi ba, sa pinakatuktok na point ng ating curve or pinakababang point ng ating curve, di ba ang slope doon is 0 dahil yung line na nandun is flat lang, horizontal lang. So in this module, meron tayong point 1, p sub 1. Okay, meron siyang coordinate na x sub 1, y sub 1. So in this part of our module, ang ginagawa natin, hinahanap natin yung equation of the tangent and normal line. So kung meron kang point dito, then may p sub 1 ka, so yung tangent line t, ayan t, di ba? Ulitin ko lang yung definition ng tangent line. When we say tangent line, it is a line which intersect or which intersect the curve at one point. Okay? So in this case, yung tangent line nag-intersect siya with the curve y is equal to f of x doon sa P1. Okay? So paano ba natin kinukuha yung slope ng isang point? Di ba derivative lang natin yung given curve. Tapos isa-substitute natin yung given point natin. Okay? So going back dito sa ating module, gumagamit tayo ng formulas para makuha yung equation ng tangent and normal line. So as you can see here, itong first natin na formula, y minus y sub 1 is equal to m multiplied by quantity x minus x sub 1. Yung y sub 1 and x sub 1, yan po yung given p sub 1. Coordinates ni p sub 1 yan. So yung slope, gaya na sabi natin, derivative lang ng curve. Okay, so dito, meron tayong inintroduce na bago na line, which is the normal line. Kung sinabi natin normal line, it is a line which is perpendicular to our tangent line at that certain point. Okay, so as you can see, yung tangent line T natin, and then ang normal line N natin is perpendicular sa ating tangent line T at point 1. So 90 degrees pag sinabing perpendicular. Okay? Meron tayong formula for normal line, may equation, itong nasa baba. But they are almost the same para sa tangent line, di ba? Ang difference lang nila is itong portion na to, negative 1 over m. So, pwede nating isipin that the slope of a normal line is the negative reciprocal of the slope of the tangent line at that certain point. Okay? So, merong time sa problem kasi nabibigyan ka lang ng equation ng isang curve tapos ang ipapahanap is normal line. So, pwede nyo gawin dyan, i-derivative nyo lang yung equation of the curve, substitute the value of the x and 1 based on the point na pinapa-analyze, and then kunin nyo lang yung negative reciprocal ng slope na yun para ma-compute the equation of the normal line at that certain point. Okay, so I hope clear yung ating explanation dito sa ating tangent and normal line sa pagkuha ng equation. Okay, so para maintindihan nyo lalo, let's proceed to our examples. So first, we have this example number 1. Find the equation of the first tangent and then the normal lines of the parabola y is equal to x squared minus 1 at the point 2, 3. Okay, so first, solve natin yung equation ng tangent line sa point 2, 3 natin. Ano? So A, okay. So sa pag-solve ng equation ng tangent line or even the normal lines, we first get the derivative of the given equation of the curve. Or dito sa example number 1 is a parabola. So we have y is equal to x squared minus 1. Pag kinuha natin yung derivative niya is y prime 2x. Okay? So since ang pinapahanap na tangent line is yung nasa point 2, 3, so yung point 2, 3 class is along the parabola. Okay? So at 2, 3. So we simply substitute the values of x dun sa ating derivative gaya ng ginawa natin from previous module. So we have y prime equals 4 or ito yung ating slope. So given that the formula for getting the equation of the tangent line at a certain point sa isang curve, so ito yung formula pinigay natin kanina, gagamitin lang natin. Ano? So yung y natin is y lang yan minus yung y sub 1 is yung sa given point natin which is 3 is equal to, yung m na nakuha natin is 4, and then yung x is retained as x, minus yung x sub 1 is the x coordinate ng ating point, which is 2. So we just simplify our values here for x minus 8. Then gawin natin standard form, ano? Naka ax plus by plus c form. So gawin natin, lipat natin yung 4x sa kabila, tapos plus y, negative 3 plus 8 is equal to 0. So we have 4x plus y minus or plus 5 is equal to 0. So pwede pa natin simplify yan by multiplying both sides sa negative 1 para bumaligtad lang yung sign nila. No? 4x minus y minus 5 is equal to 0. So now we have equation of the line or equation of the tangent line. Okay. So now, nire-require tayo na hanapin naman yung equation of the normal line ng ating given parabola sa may point 2, 3. So paano natin gagawin yun? So kanina, meron tayong nabanggit that the slope ng ating normal line is equal sa negative reciprocal ng ating tangent line. So kung so lagay ko lang m ng normal line tapos ito yung tangent line. Okay? So kung yung nakuha natin na m ng ating tangent line is 4, therefore yung m naman ng ating normal line is equal to negative 1/4. So ang formula natin kanina, di ba, is y minus y sub 1 is equal to 1 over m, x minus x sub 1. So ito na yun mismo. Okay? So y minus, yung y sub 1 is yun ulit, which is 3, is equal to negative 1 over 4, the x minus 2. So simplify lang natin yung sagot natin. Yung 4, pwede na natin i-cross multiply sa kabilang side. We have 4, y minus 3, equal to negative x. I-distribute ko na yung negative 1 sa x minus 2. You have a positive 2. Okay? Simplify, 4y minus 12 is equal to negative x plus 2. So transpose x papuntang left side of the equation, you have x plus 4y. So negative 12, yung 2 pag nilipat sa kabila magiging negative 2. So magkakaroon ka ng negative 14 is equal to 0. So therefore, you have now the equation of the normal line at point 2, 3. So, nung ginamitan natin ng formulas natin na ito, saka ito, sinubstitute lang natin yung given values natin. Yung given coordinates na x and y, tapos yung na-compute natin na m para makuha yung equation of the tangent line and equation of the normal line at the given point 2, 3. Okay, so kung i-graph natin, ganito yung magiging itsura niya. So as you can see here in the upper right of the screen, itong kulay orange, yan yung ating curve, x squared minus 1. So for you to be able na ma-graph yung x squared minus 1 na y na parabola, sundan nyo lang yung previous module natin na nasa phonics section, which is the parabola, kung paano tayo nag-graph doon. And also, itong green naman sa baba, yan yung normal line. Okay, so naka-label naman siya na normal line. Ito yung ating um, x plus 4y minus 14 is equal to 0. Okay, tapos yung tangent line naman, ito yung blue. O ito yung 4xy, 4x minus y minus 5 is equal to 0. Okay? So as you can see, yung tangent line natin is nag-intersect dun sa may parabola sa point 23. Tapos, yung ating normal line is perpendicular naman siya sa tangent. Okay, so ito yung ating 90 degrees kasi nga perpendicular. So, by observation, makikita nyo din sa nakuha natin na ah, equations ng tangent at normal line. Parang yung sa normal line, yung coefficient ng x is 1 lang, tapos coefficient ng y is 4. Pero pagdating sa tangent, nagbaligtad siya. Yung coefficient ng x na yung 4 and yung coefficient ng y is yung ating 1 na. Okay? So, medyo nagkaiba lang dito sa portion na ito. Ano? So, laging ganyan plus. Dun sa x and y na coefficient, laging nagpapalit yan when it comes to normal and tangent line. So, I hope clear yung first example natin. So now we have example number 2. Find the equation of the tangent and normal lines to the ellipse for x squared plus 9y squared is equal to 5. Okay, so ellipse is one of the conic sections na hindi natin masyadong na-elaborate in our subject. But here in our example, ipinapahanap lang naman yung tangent and normal lines ng ating given ellipse. So gaya ng ginawa natin sa example 1, we get the derivative lang nung given function or given curve. So kung ganun pala is i-derivative muna natin yung equation ng ating ellipse. So we have 4x squared plus 9y squared is equal to 25. So pag dinerivative natin yan, may 8x plus 18y dy over dx. So it is an implicit differentiation. Okay? Is equal to 0. So ito, i-transpose lang natin yung 8x papuntang kanan. We have 18y dy over dx is equal to negative 8x. Dividing both sides by 18y, we have dy over dx is equal to negative 8x, 18y. Or ito ay equal din sa negative 4x over 9y. So sinimplify ko lang class. So etong problem natin is naiwan yung ating point kung saan tangent yung ating line na pinapahanap na equation. So idagdag lang natin, ito ay nasa point 2 or negative 2, negative 1. Okay? So now we have the dy over dx na negative 4x over 9y or ito yung slope natin na gagamitin. So i-substitute lang natin yung ating negative 2 saka negative 1 dito. So negative 4 times negative 2 over 9 times negative 1, we have here an positive 8 over negative 9 or negative 8 over 9. Okay? So, ito yung slope ng ating tangent line. So, A, tangent line. So, yung kaninang formula natin na y minus y sub 1 is equal to m, x minus x sub 1, substitute lang natin yung mga given. So, y minus yung given na y coordinate, which is negative 1. So, huwag niyong kakalimutan yung sign ng given. So, yung slope natin is negative 8 over 9 times x minus negative 2. Okay, so, yung 9, i-cross multiply natin sa kabila, we will have 9. Y magiging positive 1 is equal to negative 8 x plus 2. So, simplify pa natin, we have 9y plus 9 is equal to negative 8x negative 16. So, transpose natin yung negative 8x sa negative 16 papuntang kaliwa. Magiging 8x plus 9y plus, so yung positive 9 and yung positive 16 pag nilipat sa kabila is magiging positive 25 is equal to 0. So now we have the equation of the tangent line at point negative 2, negative 1 sa ating ellipse. So for our normal line, yung slope na gagamitin natin dito is yung negative reciprocal ng ating slope sa tangent line. So ang nakuha natin kanina is negative uh, 8/9. Okay? Kung negative ito, negative din yan. So positive na yung ating magiging slope for our normal line. So equal to 9/8 dahil extremes and means tayo. Okay, kaya 9/8 na siya. So therefore, ang ating equation ng normal line is, yung y sub 1 natin is -1. Then yung slope natin is 9/8. And then x minus, x minus -2. Okay? So cross multiply natin yung 8 sa kabilang side. We have 9, we have 8y plus 8, sinorkat ko na class yan, ano? Is equal to 9x plus 18. So transpose natin yung 9x plus 18 papunta sa kaliwang side ng ating equation. We have negative 9x plus 8y. So yung positive 8 minus 18 is negative 10 is equal to 0. Or po pwedeng 9x multiply by negative 1 both sides. You have positive 9x minus 8y plus 10 is equal to 0. So now we have the equation of the normal line at point -2, -1 along the ellipse. 4x squared plus 9y squared is equal to 25. So if i-graph natin yung ating given ellipse, okay, so kung i-graph natin yung ating equation na nakuha, ano? So, itong malaking parang oblong, yan yung ellipse natin. Ano? Yan yung 4x squared plus 9y squared is equal to 25. And yung tangent line na una nating sinolve is itong blue. Ito. Yan, plus. Yan yung ating 8x plus 9y plus 25 is equal to 0. So, tangent siya dito sa -2, -1. And then yung nahanap natin na line or normal line is yung red naman natin na 9x minus 8y plus 10 equal to 0. Okay, so ganun ulit yan ay perpendicular. So 90 degrees yung kanilang angle. Okay. So we have here example number 3. Find the tangent of the slope 2 to the circle x squared plus y squared is equal to 5. So dito sa ating example number 3, ang binigay sa atin is slope. Slope ng ating tangent line. Ano? Pero pinapahanap yung mismong equation ng tangent line. So we have here circle x squared plus y squared is equal to 5. And quick recap lang, we know that kapag ganyan yung ating equation of circle, automatically ang center niya is nasa center of the coordinate plane or 0, 0 ang kanyang center. Okay, so sulat lang natin that the slope of the tangent line is equal to 2. Okay, so as usual, ang ginagawa natin, kanina, kapag naghahanap naman tayo ng slope is dinidifferentiate natin yung ating equation of the given curve. So gawin ulit natin yun, ano? So bakit natin gagawin yun? Kasi ang binigay sa atin is slope, binigyan din tayo ng, of course, the equation of the circle. Ang problem natin is wala tayong intersection point ng ating tangent line and ang ating curve o ng circle. Okay, so kailangan muna nating hanapin yun para ma-solve yung equation of the tangent line. So paano natin gagawin yun? Gagawin natin is magsasolve tayo ng equations simultaneously. Pero bago natin magawa yun, kunin muna natin yung uh, uh, derivative nito, dy over dx. So yan ay magiging implicit differentiation. Okay, so we have x squared plus y squared is equal to 5. By getting the derivative of it, we have 2x plus 2y dy over dx is equal to 0. So, transpose natin yung 2x sa kabilang side, you will have a dy over dx, then i-divide ko na agad yung 2y, both sides of the equation. Therefore, you will have 2x pero negative over 2y, or simply negative x over y. Okay, so wala tayong, di ba ang ginagawa natin kanina, pag nakakuha tayo ng ganitong derivative, sinasubstitute agad natin yung point x y, hindi ba? Para magkaroon tayo ng derivative. But this time, baligtad. Meron tayong slope na binigay. So itong part na to, simplify lang natin. We will have 2y is equal to negative x, or x is equal to negative 2y. Or ito ay x plus 2y. Okay? So, ito yung ating first equation. So, para makuha natin yung ating point na ito, di ba sabi natin magsasolve tayo ng equations simultaneously. Okay? Yung isang equation natin is yung ating given na x squared plus y squared is equal to 5. Since yung point xy is present sa ating circle and at the same time present siya sa ating tangent, pwede natin gawin is ito, ay i-substitute natin dito. Okay? So gamitin na lang natin itong x is equal to negative 2y. So we have x squared plus y squared equal to 5. So substitute natin yung negative 2y sa ating x. So may squared siya plus y squared is equal to 5. So we will have 4y squared plus y squared is equal to 5. Then we have 5y squared is equal to 5. Divide both sides by 5. You will have y squared is equal to 1. Get the square root of 1 and y squared. You will have y is equal to positive and negative 1. So huwag niyo kakalimutan na dalawa lagi yung value natin ng variables kapag nag-i-square root, diba? Kasi 2 yung degree natin. Okay? So therefore, meron kang y is equal to positive 1 and y is equal to negative 1. So for us to be able to get the x value ng ating point na hinahanap, since dalawa yan, gamit na lang tayo ng isa sa equation na ginamit natin kanina para ma-solve yung y is equal to 1 and y is equal to negative 1. So ito na lang gamitin natin. So if y is equal to positive 1, therefore our x will be equal to negative 2. And if our y is equal to negative 1, our x will be equal to 2. Therefore, ang ating point is negative 2, 1, and then positive 2, negative 1. Okay? So meaning, yung ating circle pala is nag-intersect sa ating nag-intersect yung circle natin sa dalawang line. Okay? Sa point negative 2, 1 and 2, negative 1. Okay? So kung ganun pala, dalawang beses nagkaroon ng intersection yung ating circle sa tangent line, dalawa din ang ating equation na mapuproduce. So for tangency at point negative 2, 1, ito yung equation ng ating tangent line. Ano? Y minus, so 1 is equal to, ano yung slope niya? Yung given na 2. So x minus itong negative 2, huwag kalimutan yung negative sign. So simplify lang natin, y minus 1 is equal to 2x plus 4. Then transpose natin yung ating mga values. You will have 2x minus y. Tapos negative 1, nilipat ko sa kabila. Magkakaroon ka ng positive 5 is equal to 0. So therefore, ito yung ating equation ng tangent line sa point negative 2, 1. For tangency naman, at point negative at point positive 2, negative 1 naman ano. So y minus negative 1 is equal to 2 ulit yung slope na gagamitin natin dahil magkaiba lang ng point pero parallel yan pag tinignan nyo later sa graph. So 2x minus 2. So simplify lang natin, y plus 1 is equal to 2x minus 4. So transpose the values in the equation. You will have 2x minus y. And then negative 4, tas negative 1 yan. So negative 5 is equal to 0. So therefore, ito yung ating equation for the tangent line at point 2, negative 1. So yun ay sagot nating dalawa na to. So kung i-graph naman natin siya, ang magiging itsura niya is ganito. So as you can see, yung circle natin, nung ginraph natin, di ba? Gaya na sabi natin kanina, yung given circle is nasa 0, 0 or origin ng coordinate plane, yung kanyang center, ano? So center is 0, 0. Tapos, yung radius niya is 5 or square root of 5. So kaya dito nag-fall yan, ano? So yung buo na yan, na square root of 5 yung radius niya. So, kanina kumuha tayo ng dalawang point. Etong dalawa na yun. So, eto siya. Ayan. Tapos, negative 2, 1, 2, negative 1. So, dyan mag-i-intersect yung ating tangent line na merong slope na 2. Okay? So, etong green, yan yung 2x minus y is equal to 5 or 2x minus y minus 5 is equal to 0. Kasi ito naman kabila is yung 2x minus y plus 5. Okay, so I hope clear yung ating third example. So now we have here example number 4. Find the equation of tangent lines to the ellipse x squared plus 4y squared is equal to 8 parallel to the line x plus 2y is equal to 6. So binigyan tayo dito ng ellipse, ito. And then binigyan din tayo ng line x plus 2y is equal to 6. But not necessarily that the given line, ito, is naglalay or nag-intersect dito sa ating tangent. Hindi yan naglalay kasi palang in-state din sa problem. So, ang pinapahanap sa atin is tangent lines, meaning more than one ang ating line na nag-intersect sa ating ellipse. So, paano kaya ang gagawin natin? So, hindi tayo binigyan ng point of tangency o kung saan tatama yung tangent lines along the ellipse. Pero binigyan naman tayo ng parallel na line daw dun sa tangents na yun. Ano? So if parallel ang isang line sa isa pang line, ibig sabihin ang slope nila is equal lang. Okay? So I'm not sure if na-touch na natin yung concept na yun, pero pwede nyo tandaan that the slope of one line is equal to the slope of another line if the lines are parallel. So kanina, isingit ko lang ulit na yung doon sa may previous topic natin, ano, o yung doon sa may first part ng ating topic na banggit na yung slope ng isang line is equal to the negative reciprocal of the slope of another line if they are or if the lines are perpendicular. Okay? So may mga makikita lang kayo na sign na ganito, parallel yan, and then pag ganito is perpendicular. Just in case na may ma-encounter lang kayo na symbol. Anyway, let's proceed to our example. So gaya na sabi natin, kapag daw ang dalawang linya o marami is parallel to each other, yung slopes nila ay pare-parehas lang. So ano bang ibig sabihin nun? So kunin natin yung line muna. So x plus 2y is equal to 6. We simply get the derivative ng ating given line na ito, wherein ito ay 1 plus 2 dy over dx is equal to 0. So transpose natin yung 1 sa kabilang side ng equation, tapos divide natin both sides sa 2. You will have yung slope na dy over dx is equal to negative 1 over 2. So actually ito namang slope na to is makukuha nyo pa rin kahit hindi kayo mag-derivative. Kung naaalala nyo yung slope intercept form, etong line na to convert nyo lang sa slope intercept form. So pwede rin yun. Kasi 1 degree lang naman din yan. Anyway, yung slope na negative 1 half nung ating given line na ito, yan din yung slope na gagamitin natin sa tangent lines. Dahil parallel lang sila. Okay? So, ano na next natin gagawin? So, kailangan natin ng point of tangency natin. So, try natin na mag-solve using this equation. So, kanina sa previous example natin, di ba, binigyan tayo ng slope. Meron tayong slope. Tapos, dinerivative natin yung ating given curve. Tapos, nag-solve tayo simultaneously. Try natin kung pwede natin yun gawin dito sa example number 4. So we have x squared plus 4y squared is equal to 8. Then derivative natin, 2x plus 8y dy over dx is equal to 8. Then ay 0 na to dahil constant siya. So lipat natin sa kabila yung 2x, then divide both sides by 8y. You will have slope dy over dx na negative 2x over 8y or negative x over 4y. Okay? So now we have the slope, negative x over 4y. Yung slope na yan, yan yung slope ng tangent line sa ating x squared plus 4y squared is equal to 8 or yung ating ellipse. So since yung tangent line, according to our problem, o yung tangent lines na yun, is parallel dito, di ba? So kung ganun pala, yung slope na nakuha natin dito sa line na to, which is negative 1 half, is equal lang dito sa slope natin na ito dahil ito ay para sa tangent lines. So therefore, ang gawin natin, yan ay negative 1 half is equal to negative x over 4y. So simplify lang natin yan. Cross multiply, you will have, ito, negative, negative, positive na yan. So magkakaroon ka ng 4y pag nag-cross multiply is equal to 2x or x is equal to 2y or x minus 2y is equal to 0. Okay, so meron ka ng equation number 1. So gaya ng ginawa natin kanina sa ating previous example, magsasolve tayo ng equations simultaneously para makuha yung point of tangency natin. Ano? So gamitin na lang natin tong x is equal to 2y, tapos itong given equation of the ellipse. So substitute natin yung x doon sa ating x squared, magkakaroon ka ng 2y squared plus 4y squared is equal to 8. You will have 4y squared plus 4y squared is equal to 8 or 8y squared is equal to 8. Then divide both sides by 8. magkakaroon ka ng y squared is equal to 1. Pag kinuha natin yung square root nila, magkakaroon ka ng y is equal to positive and negative 1. So, ganun ulitin natin. If y is equal to positive 1, ang x natin is magiging, gamitin na lang ulit natin tong x is equal to 2y, magkakaroon ka ng x is equal to 2. If you have y is equal to negative 1, your x will be equal to negative. So, therefore, the point of tangencies ng ating ellipse and ng ating tangent line is yung 2, 1, and negative 2, 1. So, ano nang gagawin natin? Gamitin na natin yung formula natin na y minus y sub 1 is equal to m x minus x sub 1. Okay? So, substitute lang natin yung values natin. We have y minus 1 is equal to yung m na gagamitin natin is etong 1 half o yung negative 1 half. Kasi nga, yung line na to is parallel doon sa ating tangent lines na hinahanap. So, ilan yung tangent line natin? Dalawa, dahil dalawa yung point of tangency natin. Okay? So, negative 1 half times x minus 1. So, cross multiply yung 2 doon sa kabila, magkakaroon kang 2y minus 2 is equal to negative x plus 1. So, transpose values, you have x plus 2y, negative 3 is equal to 0. So, ito yung isang equation of tangent line sa ating ellipse. Then, another, if negative 2 and negative 1 yung ating point, you have y minus negative 1 is equal to negative 1 half ulit ang ating slope dahil parallel din to doon sa may given line. So, x minus negative 2, you have y plus 1, pero cross multiply na natin yung 2, you will have 2y plus 2 is equal to negative x minus negative 2. So, transpose the values to the left, x plus 2y plus 4 is equal to 0. So, ito yung isang tangent line equation sa ating ellipse. So, if i-graph naman natin siya, ganito yung magiging itsura niya. Okay, so yun yung magiging itsura niya. No? Yung blue, yan yung given line natin na parallel daw sa dalawang tangent line dun sa ating ellipse. So, yung nakuha natin na tangent lines is yung red and then yung purple. Okay, so nakita natin dalawa yung point of tangency niya since dalawa din naman yung possible lines na dumaan sa kanya which is parallel doon sa ating given line. So I hope clear yung ating steps in example number 4. So here in our example number 5, find the point where the tangent to the curve x cubed plus 6x squared plus 9x plus 7 is parallel to the x-axis. So ito, hinahanap natin is yung point. So anong una natin pwedeng gawin? Kunin muna natin yung derivative ng ating given curve. So derivative ng ating derivative of x cubed is just 3x squared. Derivative of 6x squared is 12x plus 9. Okay, so since parallel sa x-axis, and sabi natin kanina, yung slope natin is 0. So equate natin sa 0, you will have 3x squared plus 12x plus 9 is equal to 0. Pwede nating i-divide both sides sa 1/3. Kumbaga, isi-simplest form natin, we will have x squared plus 4x plus 3 is equal to 0. So now we have a trinomial wherein it is a perfect square trinomial. So therefore, pwede natin siya i-factor out into two quantity o dalawang binomial. Therefore, yung isa ay x plus 3, yung isa naman is x plus 1 is equal to 0. Therefore, our x values will be equal to negative 3 galing dito, and then x is equal to negative 1 galing naman sa x plus 1. If we have 2 points dito, no? So find the point. Point lang kasi yung pinapahanap. So, kumbaga, maisip natin isa lang yan. Okay, so but through our solution, kasi inequate natin sa 0 eh. So meaning, dalawa yung point wherein parallel yung magiging tangent line sa points na yon sa x-axis. Okay? So pag ang ating x value is negative 3, ang ating y value is equal to, so gamitin nyo na lang class, yung binigay sa ating function. So huwag kayo malilito, baka kasi dito nyo gamitin sa y prime or sa may slope natin, ano, so mamamali kayo. Pag nag-substitute kayo ng values dyan, ang makukuha nyo is slope, hindi y value. So dito tayo, ito yung gagamitin natin. So if x is equal to negative 3, we will have negative 3 cubed plus 6, negative 3 squared, plus 9, negative 3 is equal to, plus 7 is equal to 7. Kapag naman ang ating x is equal to negative 1, yan ay y is equal to 3. So ito ay negative 3, 7, saka ito ay negative 1, 3. So meaning, yung ating curve is may dalawang point wherein parallel sa x-axis yung mapoproduce na tangent line. Okay? So ang kailangan natin is yung point lang naman. Therefore, ito na yung sagot natin. Okay? Kung i-graph natin, ganito yung magiging itsura niya. So as you can see dito sa ating illustration sa baba, sa ating graph dito, yan yung magiging graph ng ating given curve. So as usual, lagi natin sinasabi kapag third degree o cubic function ng ating equation na binigay, automatic ang ating graph is paganyan or paganito, basta pa-S siya. Okay, so mahalaga na i-graph nyo class, ano? So i-graph nyo pa rin yung ating given function para makita nyo talaga kung nasaan yung mga nire-require ni problem. So kagaya dito, hinahanap sa atin yung points wherein yung tangent line sa point na yun is parallel sa ating x-axis. So in this case, parallel ang ating x-axis dito sa green. So kung hinahanap naman ng problem, yung tangent line equation dun sa point na yun, ganun lang ulit, substitute nyo doon sa ating formula na ginagamit kanina yung y minus y sub 1 is equal to m times x minus x sub 1. But since points lang yung pinapahanap sa atin, hindi na natin ginawa yun. So we also have another part in our module, polynomial curves. We have the maxima and minima and first derivative test. So dito muna tayo sa increasing and decreasing functions. So nasabi dito sa right side of the screen, if y prime is greater than 0 or yung slope natin is greater than 0, meaning pag positive ang ating slope, yung f of x natin is nag increase habang nag increase din ang ating x value. So as you can see from curve A to B, ito po, yung f of x natin dyan is nag increase. So pag nandito ka sa part na to, yung ating slope dyan is positive, ano? So meaning greater than 0. So nasa point A ka, di ba may slope ka dyan? May slope ka dyan. Then halimbawa pumunta ka dito sa midpoint ng ating AB. So may ibang slope na dyan. So positive lahat yung slope dyan kasi papunta sa taas, pa kanan. Okay, so meaning nun, yung f of x natin is nag increase habang nag increase din yung x values natin. So next, sabi din dito, if y prime is less than 0 o yung slope natin is less than 0, meaning pag negative na yung slope, yung f of x natin nag-decrease habang tumataas yung x values. So tingin naman kayo sa arc BC. Okay, so yung, kumbaga pag kumuha ka ng point dyan sa arc BC, yung slope natin magiging pababa papunta sa kanan. Meaning negative na yung slope natin. So tumataas yung x values natin which is yung B, tapos yung C habang papunta tayo sa C. Since negative ang ating slope, bumababa yung value ng ating f of x. So yun yung sa increasing, decreasing function. So tingnan nyo lang, pag pataas yung ating curve, so syempre positive ang ating slope, increasing yung function natin habang nag increase yung x. Then pag pababa naman na ang ating curve, decreasing na ang ating f of x, then yung slope natin is negative habang yung x naman natin is pataas. So dito may tinatawag tayong maxima and minima. So yung maxima and minima, parang somehow common sense na lang, maxima is the maximum values or maximum points sa ating curve. Wherein yung minima or yung minimum is yung minimum points sa ating function. So as you can see dito sa illustration natin, sa may point B, andun yung ating maximum point or yung tinatawag na maxima. Pagdating naman class sa point C, yun yung minima o yung tinatawag nating minimum point. So at point B and point C, kanina na paulit-ulit nating binabanggit na sa point B and C o yung highest point and lowest point or the maximum or minimum point na ating curve, ang tangent, ang slope doon is 0. Okay? So y prime is equal to 0 or slope is equal to 0. May binabanggit din dito, a function is strictly monotonic on an interval when it is either increasing on the entire interval or decreasing on the entire interval. So ito yung mga kung mula umpisa ng curve is pataas, pataas na hanggang dulo. Yun yung, o kaya kapag umpisa pa lang ng function, pababa na siya, pababa na hanggang dulo yung values. So we have here the first derivative test. So ito ay ginagamit for the extremes of function. When we say extremes of the function, ito yung maxima and minima. Okay, so as you can see here, meron tayong line o tangent line sa curve natin, yung kulay-pula, increasing yan class. So kapag nandito ka sa point na ito, papunta dito sa ating maximum point, yung ating y dyan o y prime is equal to positive, increasing yan class. Pero pagdating mo dun sa pinakatuktok, zero na yung slope mo dyan. Then pag nakalagpas ka na dun sa tuktok na to, decreasing na siya, di ba? Negative na yung slope mo dyan. While on the other hand, itong ating relative minimum, ano, pag nandito ka sa curve na to, sa left side, meron ka dyan slope, yung pula, and decreasing yan class habang pumupunta ka doon sa inyong minimum point, yung pinakamababa. Then, pag nakalagpas ka na sa minimum point dito, pataas ka na ulit, magiging positive na ang inyong slope. So, dito tayo sa first graph, ito yung pag maximum point, yung ating slope is nag-change from positive to negative slope. Ngayon, kapag naman minimum point ng ating curve, nag-change ang ating slope from negative to positive slope. Okay, so sabi dito, the point at which y prime is equal to 0 are called critical points. Okay, so mayroon tayong maxima and minima na nabanggit. Ang tawag doon ay critical points. And the corresponding values of x are the critical values of x. Okay, critical points, syempre sa critical points, yung x doon is the critical values. And lastly, meron sa ating binanggit na steps dito ano, sa pag-identify o paghanap kung nasaan nga ba ang ating maximum or minimum values ng given function f of x. So first, kailangan natin isolve yung ating f prime of x or f of x prime and then i-equate natin sa 0. Dahil we know na kanina pa natin na sinasabi na kapag nasa minimum or maximum point sa isang curve, 0 ang ating slope doon. So meaning nandun yung critical value. So yun gagawin natin sa first step. Next is locate the critical values on the x-axis, thereby establishing a number of intervals. So ngayon, kapag nakasolve na tayo ng critical values ng ating function using f prime of x is equal to 0, magsiset tayo ng interval. For example, nakakuha tayo ng critical value of x na negative 3. So magsiset lang tayo ng isang value sa kanan ng negative 3 and isang value sa kaliwa ng negative 3. So negative 3, po pwedeng negative 2 yung isa and then negative 2 tapos yung isa negative 4. Okay, so ngayon pag meron ka ng dalawang interval, isa-substitute mo kada isa sa ating f prime of x. Okay, so ngayon madedetermine natin doon kung ano yung sign ng f prime of x kada interval na ginamit natin. So pag meron na tayong dalawang values ng f prime of x using each interval, punta tayo sa step 4, titingnan na natin kung ano yung na-solve nating critical values. If sila ba ay maximum or minimum. So kapag ang f of x is nag-change from positive to negative using each interval, yung point o yung critical values natin na nakuha is maximum value. Pero kapag naman nag-change yung f prime of x natin from negative to positive, ito ay minimum values. Okay, so I know medyo clouded pa yung concept na yon. So para mas magets natin, pwede tayo mag-solve ng problem. So kanina na-discuss natin ano nga ba yung maxima and minima and the first derivative test. So dito sinusolve natin the maximum and minimum values or in short, the critical values ng ating curve. So binigyan tayo ng different steps, binigyan tayo ng four steps para mahanap yung ating critical points ano, or yung critical values sa isang curve. So binigyan tayo dito ng curve y is equal to x cubed plus 3 halves x squared minus 6x minus 4. And as per first step ng paghanap ng critical values, kunin daw natin ang ating y prime of x and then i-equate sa 0 or ito yung y prime. Okay? Is equal to 0. So kunin lang natin yung derivative ng given curve. Yan ay 3x squared plus 3 halves times 2 is just 3x minus 6. So now we have 3x squared plus 3x minus 6 is equal to 0. Since pwede natin i-simplify yan, divide natin both sides or multiply natin both sides by 1/3. So magiging x squared plus x minus 2 is equal to 0. Pwede natin maging x minus 2 or x plus 2 times x minus 1 is equal to 0. So meaning dalawa yung magiging ating x values. So x is equal to negative 2 galing sa x plus 2 is equal to 0. And then x is equal to positive 1 galing sa x minus 1 is equal to 0. So therefore, these are the critical values of x natin ha. So kung ito ang critical values of x natin, pag sinubstitute natin yung x values natin sa ating original function, ang makukuha natin is critical values of y din. Okay? Kung ganun pala, if x is equal to -2, yung y value natin is magiging, pag sinabsit natin doon sa original function, if x is equal to -2, pag sinabstitute natin doon sa ating given function, makukuha natin na y is +6. So yan ay -2, 6. So yan ay isang critical point or critical value natin. Ano? Hindi lang natin alam kung yan ba yung maximum or minimum. So doon naman sa x is equal to +1, you will have y is equal to 15 or -15/2. So therefore yan ay 1, -15/2. Pwede naman yung -7.5 pero mas presentable kasi kapag naka-fraction kagaya niyan. But anyway, meron na tayong critical values. Ngayon, ang sabi, locate the critical values on the x-axis, thereby establishing a number of intervals. So, paano natin gagawin yun? Kunin natin yung dalawang value ng x, which is -2 and +1. So, halimbawa, meron ka dyang number line. So, sabihin natin, ito yung -2. Tapos, andito yung ating +1. Okay? So, ito ay parang Cartesian plane lang din. So, ngayon, kukuha tayo ng kahit isang interval. Ano? Isa sa kaliwa, isa sa kanan. So, ang kunin natin sa kaliwa is -3 na lang. Kumbaga, yung interval natin is 1 lang. No? Tapos yung sa kanan naman is -1. So, ngayon, dito naman sa 1 is, di ba 0 na itong kabila. So, pwede natin gamitin 0 tapos +2. Pwede naman din. So, una nating i-analyze itong nasa -2. So, x is equal to -3. Okay? So, isa-substitute natin yung interval na -3 and -1 and then 0 and 2 sa ating f prime of x or sa y prime. Okay, so we have y prime is equal to 3x squared plus 3x minus 6. So, ito yun. Yung dinerivative natin yung given function. So, substitute lang natin yung 3 dyan. Y prime is equal to 3, -3 squared plus 3, -3 minus 6. So, y prime is equal to 12, +12. Okay, so kung nandito ka daw sa x, ang y prime value dyan is +12. Okay, tandaan nyo lang yung +12 na yan. If x naman is -1, yung ating y prime is magiging 3 times -1 squared plus 3 times -1 minus 6. Yan ay magiging -6. So kung mula dito sa -3 is +12, tapos biglang pag nung nakarating ka na sa -1, naging negative, therefore yung ating y prime is nag-change from positive to negative value. So therefore, yung point dito na -2, 6 is yan ay maximum value. Ano? So gaya nung sinabi natin kanina nung nag-present tayo, kapag daw ang y prime or f prime of x is nag-change yung sign niya from positive to negative, yung point na nandun is the maximum value. So naka-state din dito sa ating step. Okay? So therefore, yung -2, 6 is the maximum value. So kung ito yung maximum value, automatically yung isa, yun yung minimum value. Pero i-check pa din natin. Paano natin i-check? Gamitin naman natin yung isang interval na sinet natin. So if x is equal to 0, yung y prime natin is magiging 3. 0 squared plus 3 times 0 minus 6. So 0, 0. So y prime is equal to -6. If x is equal to +2, y prime is equal to 3. 2 squared minus plus 3 times 2 minus 6. So yan ay 12. Y prime is equal to +12. So kung ganun pala, kapag nasa 0 ka yung x value, yan ay -6. So pagdating mo sa 2, magiging positive na siya. So if y prime is from negative sign to positive, therefore, ito ay minimum value. Okay? Yung ating 1 -15/2. Okay, so I hope clear yun, class. So kung i-graph naman natin yung ating given function, so as you can see, we have here the graph sa upper right ng screen. So itong ating graph is since naka-cubic function yung given, automatic mukhang S ulit yung ating graph. Ano? So kanina nakakuha tayo ng values or critical values, -2, 6, +1, -15/2. So, pag ginraph natin siya, dadaan dun yung curve natin talaga, ano? So, ito yung minimum point. And then yung ating maximum point na negative 2,6. So na-prove naman natin na sila ay maximum and minimum point by using the first derivative test. Okay? So yung step natin kanina is ginamit natin. So quick recap lang sa ating ginawa. So first, we get the derivative of the given function, then inequate natin sa 0 para makuha yung critical values of x. So after we get the critical values of x, sinubstitute natin yung x sa ating given function sa y. Then after that, nag-proceed tayo sa establishing ng intervals wherein kinuha natin yung x values, nag-set tayo ng left and right intervals nila. In this case, negative 2 yung isang x, kaya negative 3 and negative 1 yung ginamit natin. On the other hand, para sa x is equal to 1, ang sinend natin na left interval is 0 and sa right value naman is positive 2. So ngayon, ginamit natin yung x values ng mga interval na yun, sinubstitute natin sa f of x prime or sa y prime. So ngayon, nung sinubstitute natin, nagkaroon tayo ng values and nakita natin yung sign nila. So from left, nakita natin na positive 12 yung sa negative 3 na x and then naging negative 6 siya pag negative 1 yung x value. So meaning nag-change ang ating y prime or slope from positive to negative. Therefore, yung ating critical values na negative 2,6 is the maximum value of the given function. Well, on the other hand naman, kapag naman interval 0 and 2 yung ginamit natin, pag ginamit yung x is equal to 0 sa y prime na nakuha natin, makukuha natin yung y prime is equal to negative 6, which is negative. And then pag sinubstitute yung x value na 2 sa ating y prime, ang makukuha is positive 12. So therefore, yung ating y prime is nag-change from negative to positive. Therefore, ang ating critical value na 1, negative 15 over 2 is the minimum value of our given curve. So ganun lang natin identify yung ating critical points pagdating dito sa differential calculus with the given curve. So I hope clear ang ating discussion with regards to our module 9, polynomial curves. If you have questions, clarification about our discussion, you may raise it sa ating group chat or you can simply direct to me sa direct message para ma-address natin agad yung mga unclear concepts sa inyo. So that would be all for our module for today. Thank you for listening and thank you for watching our lecture video.